Okay, so now for this lesson, we're going to look a bit closer at how logarithms and exponents are tied together, right? How they can be written in different forms. So officially, the statement y is equal to a to the x is equivalent to the statement x is equal to log base a of y. So now another way of picturing that statement there is like below, right? So when we write something out as log base 2 of 16, right? Another way of stating that is 2 to the power of what is equal to 16. Okay? So what logs do, logs are actually solving for exponents, right? So when I write something out as log base 2 of 16, I'm really saying 2 to the power of something is equal to 16. So let's try another one. What if I said log base 3 of 9, right? So what this is really saying, if we were going to write this out in exponential form, this is really saying 3, right, our base of 3 to the power of what is equal to 9. Okay, so that's what that's actually. So in this case, when you see something written out as log base 3 of 9, that's just a number. And in this case, 3 to the power of 2 is equal to 9. So log base 3 of 9 is actually just equal to 2. Logs solve for exponents, right? That's what logs do whenever we're using them. So let's do one more. Let's say we had log base 3 of 27. And I was saying, okay, what is that equal to, right? Now, we could put this in our calculator, and I'll show you guys how to do that in a minute here too, but log base 3 of 27, all right, well, that's really saying 3 to the power of something is equal to 27. It's solving for the exponent here. So log base 3 of 27, well, that's 3, right? 3 to the power of 3 is 27. All right, so let's do some examples here. So it says write these exponential equations as logarithmic equations. Okay, so in this case, so this one, we've got 2 to the power of 3 is equal to 8. All right, so if we're going to go the other way, I didn't really do this one yet. We can go, okay, well, this is the same thing as, and I find a good place to start is with the base, right? This thing is base 2, so I know my expression is going to have something to do with log, come on, log base 2, right? Base 2, base 2. Those will always be the same, okay? Now, and now it's of 8, right? It's equal to 8. So it is 8 is equal to 3. So now a good way of checking this after the fact, just kind of using what we were using above there, or saying above there, is it's 2 to the power of 3 is equal to 8. You kind of see like that little pattern? I kind of do that in my mind when I'm doing these ones. So it's like 2 to the power of 3 is 8. So that is the same thing we had above there, right? Okay, so yeah, we'll practice some more of these. So let's say we had, let's do C. So if we had 10 to the power of 4, or 0, I'll just write the whole thing again. 10 to the power of negative 4 is equal to 1 over 10,000. All right, so again, a good place to start is going to be log, and then base 10, right? Because that's always base, the same base. Log base 10. And then of this, right? So it's always going to be what it's equal to. So of 1 over 10,000. And then sometimes we put these in brackets just to kind of show that it's log base 10 of this, right? Sometimes it won't be, but I think it's more clear when it's in brackets. And then that is equal to negative 4. Now let's double check that this makes sense. This is saying 10 to the power of negative 4 is equal to 1 over 10,000. So yeah, we're good to go. All right. Now, let's go the other way around. These ones I find even a little bit easier just because of that same little trick there, right? So if we had, I'll just write it one more time here, log base 6 of the square root of 6 is equal to a half. Then it's just going to be 6, right? 6. Okay, so 6, and then to the power of, right? So it's like 6 to the power of a half is equal to root 6, right? So 6 to the power of a half is equal to the square root of 6, which actually makes sense, right? When you write the square root of 6, that is the same thing as saying 6 to the power of a half. Okay. Okay, one more. Let's do just log base 3. Log base 3 of 9 is equal to 2. Okay, well that's really saying 3 to the power of 2 is equal to 9. Again, you've got that pattern, right? This to the power of that is equal to this. So 3 to the power of 2 is equal to 9. Okay, so now moving down, it's the same thing with variables. We treat it the same way. So if I want to solve, let's say for x in this case, then all I really have to do is rewrite this thing in exponential form, and then I think it'll make a bit more sense. Right? This is saying 4 to the power of 2 is equal to x. Right? 4 to the power of 2 is equal to that. And if you do that, then we can say, okay, 4 to the power of 2 is equal to x. Okay, so what is x then? Well, it's equal to 4 to the power of 2, so 16. Okay? And this one, let's say if we had 2 to the power of x is equal to 10, then we can rewrite this in logarithmic form, right? So I'm going to say base 2, so that'd be the same, here I'll write it out, 2 to the power of x is equal to 10. So then what we can do is say, okay, well then 2, right? So it's going to be log base 2, log base 2 of 10, right? Of 10 is equal to x, right? Logs solve for exponents, right? We're solving for x here, right? So then that'd be it. If you type in log base 2 of 10, then that's what x is equal to. Now, I keep saying that you could put this in your calculator. I haven't really shown you how to do that yet. I'll show you that in the steps below here. Okay, and just lastly, let's just do this one too. So again, we might be able to solve for this log just by rewriting it in exponential form, right? So what this is saying, well, I'll write it again. Log base 2 of 1 over 16 is really saying 2 to the power of what is equal to 1 over 16. All right, maybe you're scratching your head on this one too. Let's think about this differently. What would 2 to the power of something be equal to 16? Right? So 2 times 2 is 4. 2 times 2 times 2, or 2 to the power of 3, is 8. And 2 to the power of 4 is 16. So if I want to figure out what 2 to the power of something is equal to 1 over 16, well, what about this? What if I went 2 to the power of negative 4, right? 2 to the power of negative 4 is equal to 1 over 16. Because if you remember here, 2 to the power of negative 4 would be the same thing as 1 over 2 to the 4, which is in fact equal to 1 over 16, right? You go 1 to the power of 4 and 2 to the power of 4, so 1 over 16. Okay? All right. All right, now what about this one? It says evaluate 4, and then it says log base a of a. So now, this is actually going to end up being one of our log laws in the next lesson, but it also just relates to what we're doing right now, right? So if we just ignore the 4 for a second and say, let's just look at log base a, log base a of a. Okay, so we don't know what a is, but we can do the same logic. We can say, okay, if we wrote this in exponential form, this would be the same thing as saying a to the power of what is equal to a. right? A to the power of what is equal to A? Okay, so then A to the power of what is equal to A? Well, that's got to be 1, right? A to the power of 1 would be equal to A. So whenever we get this situation where we've got the same, like a base of the number, that will always be equal to 1. So in this case, when we have 4 times log base A of A, that's really just 4 times 1, right? 4 times 1, which is equal to 4. Okay, so keep an eye open for these type of situations. So another example, if I had, let's say, log base 2 of 2, well, that's just 1, right? Because 2 to the power of 1 is 2. If I had log base 50 of 50, well, that's just 1. All right. Now, common and natural logarithms. Now, let's do a common log first. So the common log is a logarithm with base 10 and is typically written as just log of x. Okay, so what I've been doing so far, let's say if I had something written as like 10 to the power of x is equal to 40 or something like that. So now, instead of writing everything like rewriting this as log base 10 of 40, you know, is equal to x or something like that, then what we do instead is we just don't write the 10. And the reason for it is because base 10 is so common, right? That's why it's called a common log. So we just do shorthand like this, just log of 40, right? This should probably be a little bit closer or in brackets. So log of 40 is equal to x, right? And we just write it like that without writing the 10. But if you don't have anything written there, it really does imply that it is log base 10, okay? Now, while we're on that note, why don't we bring up our calculator, and I'll kind of show you guys how we type these things in your calculator. So, if you have a TI 84 or some of the newer ones, some of them are easier than others. So I'll kind of show you how this is going to work. So if you type in the log, if you see that right down there, right, log, do you see how it doesn't actually give me a base? Well, that's because this is the common log. So whenever it's written as log like this, it's really log base 10. Okay, so just keep that in mind. So log base 10 of, let's say, 100, if I type that in. Okay, so this would really be saying 10 to the power of what is 100. So what are you expecting to get as an answer? Well, 2, right? Because 10 squared is 100. Okay, so log of 100 is 2. Now, if you have a TI Inspire, then when you hit the log button, you probably automatically have a little option where you could put the base like right there, right? So you get to put in base 10 or base 2 or base 3 or whatever you want. You just get to put it in right there. If you leave it blank, then it's going to assume that you mean log base 10, okay? Now on these ones, it doesn't do that by default, and it took some searching on these ones. If you type in, you might have to memorize this one, alpha, right? And then you see F2 up here. And if you type in that, you're going to get a few options here. And you see number 5, how it says log base. Well, you can go down to that one, so log base, and then push enter. And if I do that, now it gives me the option right there to put in whatever base I like. So I could put in like base 2 of 40 or whatever. Okay, and it'll tell me what that equals, right? Okay, so, and I can't remember which versions of the TI though. Some of them just do that by default. So if yours is like mine though, then that's like a nifty little thing. You can just press alpha and then F2. And then that's that number 5 there, log base. Okay, so it's not in the most obvious place. Okay, so now moving on to natural logs. So the natural log is the logarithm with a base e, and it's typically written as lnx. Now let's just talk a little bit about what e is. So e is something called Euler's number, and it just comes up quite a lot. It's a universal constant, right? So it's kind of like pi in that sense, where it's a number that shows up in a lot of different places. It gets used a lot in science. So it gets used so much that it has its own notation, right? So what is e as far as numbers are concerned? Well, let's punch that in. I'll just kind of show you. So E would be, so on your calculator, you have, well, you see down here, you can't really see it very well on my screen, but you've got ln, which is the natural log, right? Written like that. But then in blue, it says e to the power of x. So let's just show you for a second what that e is. So if I go second, and then that one, right? That's going to give me e to the power of, and let's just put 1 so I can actually show you what this number is. Okay, so e is the number 2.7182, yada, 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 right? It doesn't really matter what that number is as far as we're concerned in 30-2. It just know that it's a number that does come up quite a lot in science, so it gets its own notation, and it's about 2.7. It's also an irrational number, right? So this is like pi, where these numbers would never repeat. Okay, you'd never find any kind of pattern in this, even if you went like a million digits, a billion, or even a trillion digits, right? It's never going to repeat. Okay, and then so the opposite of this now is going to be the natural log, right? The inverse function. So if I type in, let's say, the natural log, so ln of 50, then that really is the same thing as typing in log base e of 50, right? Natural log of 50 would be, yeah, some number, also an irrational number. But yeah, so if I had ln, I write it a little different with a, yeah, fancy L. So natural log of 50 is the exact same thing as writing log base e of 50. So no difference there. We just don't, you would just never typically write it this way. Okay. Okay, so this example is really saying evaluate log of 1,000. So log of 1,000. This is a common log, right? Because there's nothing written underneath here. But we know that that really means that it is base 10, even though we don't write it down. So remember what this is saying. This is really saying 10 to the power of what is equal to 1,000. Okay, so 10 to the power of 3 would be 1,000. Okay? And that's just using, yeah, this top line here on this table that we were looking at. Okay, evaluate log of 500 using your calculator. So, yeah, so you guys can type this in, just log 500. So that would be log, oh, I can't just type in there. So log of, what was it, 500. Enter. So we get that number, right? 2.698, yada yada. Notice that this says approximately equal to. That's what the little squigglies mean. And the reason why it says that is because this is an irrational number, right? We would have to round that somewhere. So it's not exactly equal to this. It's approximately equal to this. Okay. All right, so now we have the same problem I was talking about above, where if we have log base 2 of 10, and I want to write that using either common log or natural logs, then we have to establish some more properties here. So here is going to be our laws of logarithms. Now, laws of logarithms is actually your next lesson there. But I'm going to go over this first one because it might be important, especially if you have a calculator that doesn't allow you to change the base. Like I was showing you, right, that alpha F2, where it doesn't let you do the log base part there. Because if we didn't have that, then how would I ever figure out what, you know, this was, log base 2 of 10, right? So if I had log base 2 of 10 and what that's equal to, because this is saying 2 to the power of something is 10. And that's not going to turn out so nice, right? That's going to be like an irrational number. That's going to, like, it's not going to be a nice, perfect number there, right? So how do we solve this? Well, we can utilize something called the laws of logarithms, or sorry, the change of base, which is a law of logarithms here. So let's write out our problem. Let's say that we had that one above, where it was log base 2 of 10. Okay? Now, according to this law, then my b value is 2. Okay? And my c value is 10. So they're saying that this would be the exact same thing as writing. So now let's just keep that in mind. So b was 2, c was 10. So now this would be the same as saying log base, I'm just going to leave this as a for a second, like we don't care what it is, but a, and then of c, and c was 10, right, in that example? Right, this was c and that was b, over, and then the bottom part here is log base a of b. So log base a of, and then our b value was 2. Okay, now, do you see the kind of pattern that happened here? That it's like log base something of 10 over log base something of 2. It's kind of easy to remember because the 10 is like over top of the 2 in this a little bit. So the 10 is over top of the 2 when you write it out. And now the log base a, that means it doesn't matter what base we use. So why don't we just use log base 10 or just, you know, the common log? Why don't we just write this as log 10 over log 2? Okay, so if you have a calculator that doesn't allow you to type in log base 2 of 10, well, you should get the exact same answer if you write in log base 10 over log base 2. So let's try that one. So we could go, so I'll clear this. Here, I'll type in both. So if you have the other way, that'd be, you can go alpha f2 and then log base, right? So then that one. And this would be log base 2 of 10, we said, right? And that would be approximately equal to that. Now, I was saying that that should be the same thing as just saying log, right? Just using just our common log of 10, and then close the bracket there, and then divided by, and then common log of 2. And then equals. So you do see that we end up getting the exact same thing, right? And that's not that much harder, is it? So you just have to type in log base 2 of 10 as log 10 over log 2. Hopefully you kind of see that pattern, right? The 10's a little over the 2. Okay? Now, this one's kind of saying that we could do it with, well, so if we had log base 2 of 10, we could write that as log base e of 10 divided by log base e of 2, which would really just be the same thing as the natural log of 10 over the natural log of 2. So that's no different than what we just did here. Let's just try it, right? The natural log of 10 divided by the natural log of 2. And I'm expecting that we're going to get the same answer, right? And there you go. So all of those are equivalent, right? Different ways of doing it. Okay, so I'm going to leave that one there.